Hello, this video is intended for those that might be using this C++ software that I have given you and might be trying to use it with a digital design of some type. So I'm going to show you that the software works, in case you've tried it and didn't work. And all I'm going to use is this function. These are functions. This is one function of my decoder. And that's the only one I'm going to use. The encoder, I'm just going to remove that and I'm going to remove the other ones. And what I'm doing with this software, I'm going to put some slashes in it. That removes it. Just doing that removes that command. But what I'm doing is I'm sending in every possible state of the truth table to test the decoder. And this is the only one I'm going to use. So it's every possible state. And then it shows you the output. Now that I've done this, first I'll run this to show you, that this is the one I just did. It's test 5. And I'm going to recompile it like this, because this command I'd run earlier to compile it. But first I got to save it. First, what I'll do before I save it, I'll go ahead and compile it, then I'll run it just to show you that it's working. So that's compile, and then I'm going to run it. Now it runs. It's the same thing as the previous. So now I'm going to save this. Now that I've made these changes, I'll save this. Now I'll compile it again. And then I'll run it again, and now you see a difference. Now it's only showing the decoder. That's it. Because I made these changes, and then I saved it, then I recompiled it. So the decoder is it's showing every possible state for the input. So I got a 1, a 1 0 1 1, 1 0 0 1 0 1, 1 1 0 1 1 1. So it's showing the output for every possible state for the inputs. That's the truth table, and this is actually how it works. That's how this circuit is designed, and that is this part of it down here, the decoder. And what this decoder represents is this circuit right here. Everything in that little area, I don't know if I can highlight it like that. No, I can't move stuff around because it's a schematic design. I can't highlight. What I can do is this little number right here. Pull up this. It represents this part of the circuit. That is that is this function, the decoder. The outputs of these are buffers. I have to run it through a buffer so that I can drive the relays, because it probably won't have enough current to drive the relays on the output of this. It'll turn LEDs on and off, but it may not have enough current to actually drive the circuit that I want to drive. This part of it is the other part of it down here is just NAND gates. That is the encoder. That is this part of it. And that is for a rotary switch. I want to have an input for a rotary switch, and I want to have it go into the buffers. That way I want to select either I'm using the FT232H board, which is the interface to the computer, or I can use a rotary switch and do it manually. Like I want to be able to select with this buffer. I'll be able to select either connect to a computer or connect to a rotary switch. And I want to prove that, but I have to build this board before I can do that. I don't have the money and the parts to do that. Although it's only like $30, total $50 just to build the part, get the parts and build it. I just don't have the money to do that because the cops are hiding the truth about my daughter being alive, and they think it's funny to laugh in my face. They mock me instead of telling the truth. They know the truth. They've been doing that for 6 years, but they'll put me in jail, threaten me with their guns or badges, pull me over and laugh in my face. They will not tell the truth. So because of that, I'm homeless. I can't afford to buy my own groceries. I can't afford to do anything. All I can do is sit here and wait for the stupid Oklahoma Carter County Police to tell the truth about the police faking my daughter's death, faking Dale Earnhardt Sr.'s death, faking Eddie Van Halen's death, faking Kobe Bryant's death, faking multiple deaths, and then faking 9/11, and then hiding the truth about it so they can torture me in the city. They conspired to do this since I was in the 6th grade. Actually, before the 6th grade. Nobody will tell the truth. What's a person supposed to do when the cops will conspire against your life? So anyway, I'll show you how this encoder part of it works too. All I have to do is go up here, and first I'll go back to this part of it. You can see this one says decoder when I ran it. I'll run it again so you can see that, and I'll even compile it, and then I'll run it again to show you. It's the decoder. Now I'm going to make it where it's just the encoder. To do that, I'll do this, back this up. Control S saves, but I'm just going to go up here and do this, save like that. If you look at it, it says if I press Control S, it would have saved. And now I have to recompile it over here, and then I'll run it again, and now it's just the encoder. See, it says encoder. It doesn't show anything else but encoder. And that would be the truth table for the encoder. That would be this part of the circuit down here. This other AND gate that's in the encoder, I'm just connecting the two inputs together. I'm not pulling it high. I could actually do it on this circuit too, but I just decided to pull it high for some reason. That would be this part of it right at the very bottom, encoder. So that's just a description. That way you can, if you wanted to change, the circuit, add another AND gate into it, you can do that. You have to change some of this stuff up here. And, I could put other stuff. I could put OR gate in here. I could do all kinds of stuff. It's going to change the output. I'll let you figure that out. It's not hard to do.